Hi class, this is Neil, and this is lesson 5, the unit circle and reciprocal trig functions. In this lesson, we're going to learn about reciprocal trig functions and how we can use them to solve problems involving both right triangles and circles in the coordinate plane. All right, let's look at do now question 1. The terminal side of angle theta in standard position intersects the unit circle below in quadrant 3 at the point negative 0.65 comma y. Determine to the nearest degree the measure of theta. All right, so let's kind of sketch out some of the things we know in this problem. Well, we know where quadrant 3 is. It's negative x and negative y. We're given a point here, and that point is negative 0.65 as our x value. We don't know our y value, but we do know that the point is in quadrant 3. We know that that's the terminal side of an angle in standard position. So we can sketch the initial side of that angle. We can sketch the terminal side of that angle. And that is the measure of angle theta. And we don't know what that angle is. Now, I'm going to go ahead and draw in my reference triangle here. Give myself a little bit of a head start. So that's the right triangle formed with an acute angle that's on the terminal side of that angle and the x-axis. There's my reference triangle. Now, because this is a unit circle, I know the radius is 1. Anytime you see the word unit circle, you should remember, oh, that means the radius is 1. The radius is any line segment that goes from the center of the circle to the edge. So the hypotenuse of our triangle here is 1. All right, if you think about what this x value here tells us, well, that tells us the length of the base of our triangle, or the adjacent side. We don't know y. We don't know what our y value is. All right, so we need to find the measure of angle theta. We know these two sides of the triangle. Negative 0.65 is our adjacent side, and 1 is the hypotenuse. Okay, so thinking about our trig ratios, we're going to have to use a inverse trig function to find the angle, and the trig function we're going to need to use is cosine, because that's adjacent and hypotenuse. All right, so let's set up our equation. We'd have cosine of theta equals negative 0.65 over 1. Now, just for kind of ease of doing the problem, we can simplify that fraction before we do our inverse trig. All right, now I'm going to do negative cosine of negative 1 of both sides. It's going to cancel everything out here, and I'll have theta equals cosine negative 1 of negative 0.65. All right, let's turn to our calculator. And I already have that input here. So cosine negative 1 of negative 0.65 is 130.5. So to the nearest degree, that is 131. Now, we need to pause for a second and ask ourselves, does that make sense in the context of this problem? Well, let's I'm going to erase some of the information we have here in our unit circle that we don't necessarily need to solve the rest of the problem. All right, let's go back to just our angle. So that's theta. Now I'm going to draw in our guide angles, or our quadrantal angles, so 0, 90, 180, 270. We know that our angle is somewhere in quadrant 3, so it has to be between 180 and 270 degrees. But the angle we found, 131 degrees, I'll do that in a different color, is here. Somewhere around there. All right? One thing we should ask ourselves is, all right, this is a 131 degree angle here. But that's not the measure of theta. Theta is a bigger angle than that. One thing I could do to find out what that angle is find the measurement of that acute angle here, which would be 180 minus 131. And that is a 49 degree angle. And now if this 49 degree angle is what's left over to 180, to figure out what this whole angle is, so that whole angle is, we'll need to take 180 and add 49 to it. And that would give us a 229 degree angle. So that's my final answer. Theta equals 229. All right, that's the end of the do now. You can pause, take notes, and I'll see you in the next video.